Hello, everybody. Let's go ahead and get this class started. I hope you all had a great weekend. I was sick all weekend, and I'm still kind of sick right now, so sorry. I'm doing the best I can, but if I start saying some wacky stuff today, that's the Dayquil talking. It's not me. We're going to try and get through it as best we can, though. And please just bear with me. It'll be fine. You had an assignment due today, I believe. The Tech Jobs console assignment was due today. So if you have got that finished and submitted, great. If not, then we will help you out with it today. We got time today. We can work on that. Before we do that, though, I wanted to talk about today's prep work and do a little review session. Before I get started, are there any questions about assignments or other stuff before we hop into review? All right, so the prep work for today was a continuation of the prep work that you did and the work that you did in class last Thursday based on objects. So we're talking about Java objects now, which if you haven't already noticed are pretty significantly different to JavaScript objects in some ways. So let's continue that conversation and take a look at some object-oriented examples today. First up, what is a final field, or I guess maybe a more proper term would be a final instance variable? Sorry, I use the term field and instance variable interchangeably. I know the textbook uses instance variable. Yeah.
So basically like a constant. Something that's never going to change.
Yeah. Something that is never going to change. We don't want it to change. So I could set a final value once, and then what happens if I try to set it again? What happens if I try to change it?
Yeah.
It's going to give me an error. It's going to cause some kind of a problem for me. It's going to crash my program. So I can set that value once, and then I can use that value all I want, but I cannot change it from that point on. So this is a very important designation. It's actually more protection against ourselves than anything else, right? Ourselves and other programmers. The computer's not going to change that value unless we tell it to. So we're just kind of protecting it against ourselves coming back later and telling it to change that value unnecessarily, or some other programmer, some other piece of code. We also have this idea of static variables and methods. And non-static variables and methods. So what's the difference between something that is static and something that's not static? It's an important distinction for us to make. Did anybody get a good feel for that? This is one of the trickier object-oriented concepts. Yeah.
Static methods are shared by all instances.
That's correct. That is a great way to describe it. So if something is declared as static, whether it's a variable or whether it's a method, that means that it's shared by all instances of a class. That is exactly the right way to describe it. So if I want to access that static variable or that static method, what do I have to do? How do I actually access it in code? What would I type out? We've actually probably seen some static stuff before. Have we done random numbers in Java yet? I know you've probably done it in JavaScript, but I'm trying to remember if we've done it in Java. If we want to access a static field or a static method, instead of calling it on an instance of the class, we just call it on the class directly. So if I have a static variable in my menu class that you worked on from Studio last week, I would say menu dot. So I'd call it on the class directly. And you can usually tell easily between the two because class names are typically capitalized, whereas if I have an instance of an object that's going to be in a variable that does not start with the capital letter. So that's one quick way that you can kind of distinguish between whether something is being used statically or non-statically. If I want to call a non-static method, so this is actually kind of the next thing. If I want to call a non-static method, how do we call a method on an object? What do I need? We were just talking about it a second ago. I need an instance of that object. How do I get an instance of an object? What do I have to do? I have to use the new keyword, and then what else? What's the other part of that equation? I'm sorry? Import it. Not quite. There might be some importing involved. Yeah, there might be. But there's one particular piece that we need. It has to do with like building or the constructor. I have to call the constructor, right? I have to call the constructor. The constructor is what makes a new instance of an object for us. So once I have that instance, once I've called the constructor, I've made an instance of that object, how do I call a method on that object then? What's the code look like to do that? Name of the objects, dot, and then the method that I want to call. And then any parameters that I need in parentheses, right? So we use the dot notation, instance dot method. If it's a static method that I'm trying to call, it'd be class name, right? Not an instance, but the class name itself, dot method. So when should you do one over the other? When should I choose to write a static method versus an instance method? That's a more difficult question to consider, I think. Has anybody got a feel for that? When static methods are useful versus non-static methods? We can look at it from the big picture and think about the difference between the two, right? Do I want this to apply to a specific instance of the class, or do I want it to just be a general method available to everything, available to all instances? A lot of times you'll see static methods used when an instance is not necessary, and a classic case for that is mathematics. So like if I'm taking the square root of something, I don't need an instance of an object to compute the square root of something. I just need a number, right? You give me a number, I'll give you a square root. There's no objects involved in that transaction. That is a classic example of a static method. Taking the so there's a lot of math-oriented things that fit naturally with that, but it doesn't have to be math-related in order for it to be a static method. We can, as programmers, we can choose whatever methods we would like to be static or not. I will say, however, that it's probably far more common to see non-static methods than static methods. You will write static methods, that is a fact, but you'll write far more non-static methods, instance methods, than static methods. All right. What is toString? What is the toString method for? Yeah. Oh, did you have a question? Oh, okay, that's fine. It's all good. Anybody else? toString. Name's trying to help us out here, right? I'm converting something to a string. What am I converting to a string? Yeah. An object. Yeah, I'm taking an instance of an object and converting it into a string. And I actually have a lot of flexibility when I do that. So consider, what's going to make the cut to be in the string? That's the decision that we have to make. What values do we consider important enough to be in that string? So if you're writing a toString method, you should be looking at your instance variables, your fields, up at the top of the file and deciding, is this important enough for me to see? And you might decide that you want to include all of them, and that's totally a possibility. That's totally an acceptable choice. And you might decide that some of them aren't necessary and you want to leave them off. That's totally an acceptable choice as well. It's up to us as programmers to decide what makes that cut. And that's a similar question that we're going to be asking ourselves when we take a look at this next method, equals. What's equals about? Yeah.
It returns a boolean if it equals another.
Yeah, so I'm comparing two instances of objects, right? I'm comparing two instances of objects, and I want to know if they're the same or not. We had the same question to answer for equals that we had for toString. How do I define equality? It seems like a strange question. The obvious way to answer that question, and what I hear a lot, is we'll just compare all of the variables, right? Every single one of them, just compare all of them And if they're all the same, then those two objects must be the same, right? But there are situations in which we may not want to include some of those variables in the comparison. The classic example of this is to think about dates. So some dates we have marked as special dates because they are holidays. They represent a specific holiday or specific event, right? But actually, not all of us are going to agree on what days are holidays and what days are not holidays, right? A day for you might be a holiday, but it may not be a holiday for me or some other person. So if I'm comparing two dates, right, the fact that that date is a holiday or not is actually not something that I would consider to be part of determining equality. Does that make sense? If I have a date that's marked as a holiday and a date that's not marked as a holiday, well, they could still be the same date, right? What really matters is the month, the day, and the year. We have to compare those values to determine whether a date is equivalent. Whether that date is considered a holiday or not is very subjective and should not enter into this question of are two dates equal to each other. That's one example of why we might not want to include a variable in our equality measurement. But it is up to us as programmers to decide what variables are going to make that cut and what variables are not. Fortunately, IntelliJ and most good IDEs can help us out with both of these methods. We'll see some examples of that later on today. One final question, though, before we start doing some coding. We already have a way to check equality, right? Called double equals. So why do we need to mess with this equals method? What's the point? Yeah. We can attach it to an object directly. So this definitely is an example of an instance method, right? So we can call it on an object. That is true. But I could call double equals between two objects as well if I wanted to, right? Yeah.
So both the default for equals with the friends and the double equals are looking at a memory location as opposed to specific values or whatever we might define that we want to check.
Right. So it's the difference between there's actually two different forms of equality that we're talking about when we talk about these two ways of checking to see if things are equal. When I use double equals, we are quite literally looking at the memory addresses. That's what you just said. We're looking at the memory addresses. We're asking, is this the exact same object, right? Does it live in the same spot? Whereas if I'm using the equals method, I'm actually opening up that object. I'm looking at the values that that object contains and seeing if they are actually, in fact, equal to each other. It's the difference between if I have two, I don't know, I'm thinking about toys for some reason today. If I have two blocks in my hand, right? Two red blocks in my hand, and they're the exact same size and they're the exact same shape, right? That would satisfy the equals method. That would satisfy that test. They're the same size, they're the same shape, they're the same color. For all intents and purposes, they are equivalent blocks, correct? But they are two distinctly separate blocks. It would not satisfy double equals. They take up two different positions in space. They are not the same object. They are two objects that have equivalent properties, equivalent instance variables is the way we talk about that in computer science. So equals is checking the instance variables, whereas double equals is asking, is this literally the same object that I'm talking about? Does that make sense to everybody? Are there any questions about that? All right, fantastic. I've got some coding exercises for us to take a look at next, but before I do that, is there any questions about any of the stuff that we've been talking about or anything else from the prep work that you were hoping that I would chat with you about today that I didn't include on the review before we hop into some coding stuff? Yes?
Have you have a few minutes to go over the exercise per day?
The exercises? Yeah, sure. We can go over the exercises. Do I have them pulled up? Let me see here. Well, that's the studio from last time. The ones with the student?
Yes.
Okay. So get grade level. Excuse me. Get grade level wants us to return, their class standing based on the number of credits that they've earned. So we can take a look at this. I believe this is based off of the student object. In fact, they already kind of gave us a spot for it, right? We just need to set it up. So we want to look at the number of credits and then tell you whether it's a freshman or a sophomore. What code structure am I going to use to pull this off? I need to make a decision here, right? What code structures do we use to make decisions? If statements. If statements are used to make decisions. So if, and then what's keeping track of my current credits? Well, if I take a look at the variables that we got up here, our class variables, we've got a variable called number of credits that seems like it should do the trick. So number of credits, if it is, what were those numbers? Less than, so if it's less than 30, right, then we're a freshman. Oops. Return freshman. Else, if it is less than, and actually I'm breaking one of my own very important rules here. I always like to use this out in front of my variables, even if it's not strictly necessary for me to do so. What is this? It's a review from last week, kind of. What is this? The object, or it's the instance that this method has been called on? I think one way to think about this is, do we have a main method? We do. One way to think about this, right? If I look at this method down here, I create a student, correct? And then I call getName on this particular instance that I created. So when I run getName, when I run this particular chunk of code here, I go to getName, and it doesn't have this in it. Thanks, guys. This is equal to Sally, because that's what was on the left side of the dot, right? That's how to interpret the this keyword. It's whatever instance is on the left side of the dot, whatever instance the method is being called on. So, all right, and then this dot number of credits is less than 60. We'll do sophomore, whoops. I think this is fairly straightforward from here. It should just be less than 90 for a junior. And then we don't even need to check the last one. We've made it this far, it must be a senior. That one was fairly straightforward. The next one, the add grade method, is a little bit more complicated. Are there any questions on this before I take a peek at add grade? So add grade, I think, is complicated not necessarily because the objects are tricky, but because the math is a little bit tricky for this one. Computing GPAs. So it says update the appropriate fields, number of credits, and GPA. And the instructions here give us the math. GPA is the total quality score divided by the total number of credits. And actually, here's a good step-by-step. It's actually giving us step-by-step exactly what we should be doing here to compute the new GPA. So I need to multiply the GPA by their current number of credits. That's going to be called the quality score. And what's the type of that going to be? If I multiply GPA times the number of credits, what's the type going to be? It'll be a double because GPA is a double. Yeah. So double, whoops. What did I do? Sorry. I'm in the wrong place. It should be down here. Double quality score equals this dot GPA times this dot number of credits. The next step then is to use the new course grade and course credits to update their total quality score. So that means that we need to take the grade that was given to us and the course credits that were given to us and update the quality score accordingly. So course credits times the grade is our new quality score, and we want to add this to our old quality score. Like so. And then we're going to update the number of credits and compute the new GPA. So the number of credits will just be a simple addition plus course credits. And then the new GPA should be this quality score divided by the number of credits. It's 4 lines of code here, 4 steps to pull this off. None of these lines of code is terribly complicated. It's the arithmetic, the math, that's a little bit complicated to do this setup. That's usually what trips people up on this particular problem. And then the last exercise, which is a good one, I wanted to talk to you about this today actually, were to incorporate toString and equals into the student class. And there's 2 ways you can do this. I can write toString myself if I want to, or I can have IntelliJ do it for me. And I think the prep work showed you how IntelliJ can help us out with some of these, right? I think that's the way I prefer to discuss with you. For IntelliJ to help us out, we have to go to the code menu and then generate, is it down here at the bottom? Where is it? I'm sorry? I thought it was. I thought it was in the code. Oh, here it is. It's at the top. Generate toString, and then it pops up a window, and this is that decision I was talking about earlier. We have to decide what makes the cut here. You might decide that all of these are important to include in the string, and that's fine. I don't have a problem with that. I don't think there's necessarily anything wrong with including everything here. And IntelliJ will give us a string that includes all of those. And we can do the same thing for equals as well. If I go to generate, notice that equals has a friend called hashcode that always comes along with it. Did anybody take a look at hashcode and get a feel for what hashcode's doing? I know it wasn't maybe directly covered in the prep work. Well, let's take a look at it now and see if we can figure it out. Here again, we have to make a decision. What fields do we want to be included for determining whether a student is equivalent or not? So does anybody have any objections about including all of them? Does anybody want to make an argument towards taking one out? No? I mean, I think that's a very compelling argument, actually. Taking out everything but student ID, I would say, is not necessarily a bad way to go about it. That's really what matters. If my system is set up correctly, that's what I would hope would happen, right? The ID is enough for me to identify whether the student's the same or not. Or in other words, if I have 2 students with the same ID, 2 separate students with the same ID, I got problems, right? I've got big problems. But you could argue then that including the name or even these other ones, number of credits and the GPA, could be important to sort of back that up, right? Back up that decision, just to really make sure they're exactly the same. I think number of credits and GPA are a bit of a harder sell. What if I'm looking at student records from the past? I could be talking about the same student, but their GPA could be, from 3 semesters ago, and it may not be current, right? So I think that's actually a harder argument for me to include for equality. When whether I'm talking about the same student or not. Same with the number of credits, correct? If I'm looking at student records from their freshman year versus their senior year, I'm talking about the same person, talking about the same student, but they're going to have different GPA and a different number of credits. So including those as equality might be a little misleading. I certainly wouldn't be opposed to including the name, though. Although, you could make the argument if we want to play devil's advocate here, like what if somebody changes their name? That's certainly possible. Not common, but possible for people to change their names, in which case I could be referring to the same person and they don't have the same name anymore, and I wouldn't necessarily detect that. So maybe ID is the only foolproof way of doing it, right? You really have to understand your own program and make your own design choices here. There's not necessarily going to be a right answer or a wrong answer. The answer is how you expect your program to behave and the desired behavior that you want your program to have. So regardless of what you decide to do, IntelliJ will dutifully generate equals here for you and also generate hash code here for you as well. Have you guys talked about hashing at all in the JavaScript unit? No? Okay, well, I think we'll probably talk about it sooner or later when we get to more security-related stuff towards the end of the class. But for now, you can understand that hash code is the way of converting an object to a number. So I'm taking an object, converting it to a number, and then I should be able to compare those two numbers to determine if they're the same or not. Well, it's a little bit more involved than that. We'll get in more detail about that later on. What really matters is equals. And I have to be honest with you all, I don't think I've ever manually written an equals method in my entire life. I've never had the need to. I've written toString methods before. Sometimes I want my string to be formatted in a particular way. So I found it useful to write out my own toString methods from time to time. I don't think I've ever written an equals method. Yes?
Quick question. The @override, is that just like a comment or that shows that you used IntelliJ?
Yeah.
Yourself?
Yeah, so this @override here is excuse me, is telling us that this method already existed. The equals method already existed. Same for hash code and toString. And we're saying, no, we don't like the method that already existed. We want to come up with our own version. So I'm going to override the version that was given to us and use my own version instead. This will make a lot more sense when we talk about inheritance in a week or two.
So if we didn't use IntelliJ and we wrote it ourselves, would we need the override?
Would you need the override? I think if you take it out, it's still smart enough to figure out what you're trying to do. I do also think, though, that including override is a good idea just to indicate that that is, in fact, what you're doing. You're erasing the old method with your own version. To get into a little bit more detail, where do these methods come from, right? I said they already existed and we're overriding them. In Java, everything is an object. Quite literally, everything is an object. There's a class called object that provides equals, provides toString. And if I don't tell you what I want equals to be, if I don't tell you what I want toString to be, it's going to use whatever is in the baked-in default object class, which I can tell you right now is almost never what we want. That is like, I can't remember a time that I've purposefully used those methods. I almost always want to override those with my own implementation. We still have more time, so I would like to do another coding example with you, but before I do that, are there any questions? Any questions about this? All right. Okay. So I wanted to do a little object exercise with you based on this is sort of a classic computer science exercise, kind of a rite of passage in my opinion. We're going to create a little bank account class. This will review some of the stuff that you did last Thursday, but we'll also do the stuff that we were talking about today as well. And so I've already kind of set up some variables for us. A bank account, it's going to include a balance and an ID. And just real quick, there's a relationship between the instance variables and the object that they belong to. Does anybody know what the relationship is? How would you describe that relationship in English if I want to tell you what instance variables an object contains? So the relationship that I would use to describe the relationship between the instance variables and the object is, I'd say it's a has a relationship. A bank account has a balance. A bank account has, I used ID here, but maybe it'd be more accurate to say bank account has an account number. I will literally say those things in my head as I'm creating a class, right? If I can say it and it makes sense, it feels like it actually makes sense, then that to me is an indication that this is a good instance variable to include in my class. If I say it out loud and it doesn't make sense, that's an indication to me that that variable is in the wrong place. Maybe it belongs in a different class. Maybe it should be an object of its own. I don't know. Maybe it should just go somewhere else, but it shouldn't go here. So there's that has a relationship that you should be asking yourselves. You should be kind of replaying in your head when you're creating your classes. If I tried to say, bank account, excuse me. If I tried to say bank account has a, I don't know, what would be a counter example here? Bank account has a bank or a branch. I would actually think that's kind of the opposite. A bank has a bank account, right? Or actually has a whole bunch of bank accounts, has a lot of bank accounts. So kind of takes ownership into account here. Who's responsible for these variables? Who owns these variables? Once we got these variables, the next thing that gonna want to code up is probably what? First thing that I expect to see at the top of the class after the variables is, it is the name, but it's the name used for a particular purpose. The constructor, right? So bank account. And now I actually have a decision to make. So what is if you could describe the role of the constructor in one sentence, right? The role of the constructor is to what? It's got one job. What's the one job of the constructor? I'm sorry? It is to create an instance of an object, but really, how does it do that? What's the mechanism that it uses to do that? Assigning values to variables. The role of the constructor, the one job of the constructor is to make sure that every single variable that I have in my class has a value by the time it's finished. That is how we create an instance. An instance exists when the variables within my class have values. So I have to decide where these values are going to come from. So balance. If I go to the bank, I want to open up a new bank account. The balance of my new bank account is however much money I give to the bank, right? It's based on me. It's based on however much money I give to the bank, and I say I want to put it in this account. So that's an external value, right? That's something coming in from the outside world. Those kinds of things are going to be parameters into my constructor. So I'll include a balance here. Now, if I go to the bank and I say I want to open a bank account and I want my bank account number to be 7, what are they going to say back to me? Too bad, right? I don't care what you want. I don't get to make that choice, right? Making the choice of an account number is not up to me. It's not open to outside influence. That is something that the bank has decided. So things like that we may not want to be included as parameters into the constructor. So for things that are parameters, it's usually very straightforward to set them, right? But for things that aren't given to us as parameters, we have to make a choice here. Remember, the role of the constructor, the one job that the constructor has is to make sure that all of these instance variables have a value by the time the constructor is over. So the balance is satisfied. We have checked that box, but we still need to resolve this account number. And one thing that we could do is we could just say, all right, I'll just set it to 7, right? I can code in a value here, but that doesn't really feel good. Now all of my account numbers are 7. That's gonna cause a big mess. Yes?
Could you put it as a 0 now, 0 to multiple?
So could I put it as a 0? I could put it as a 0, but I still feel like that's gonna be a little problematic, right? It's going to be a little problematic. Actually, let's think about this at a bit of a higher level. The bank account chooses what my account number is supposed to be. And so the bank must have some idea of what account numbers are available, or the bank must have a way of choosing what that account number is supposed to be, correct? And so there is one number that is shared across all instances of bank accounts that I can use to pull the next account number. What does that sound like to you? When I have a variable that's shared across everything? It's a static variable. It's a static variable. I can have a static variable, static int, next account number. And unlike the variables that we see in our constructor, because it's static, I'll just go ahead and assign it up here, right? Next account number will be 1 or 0. It doesn't really matter. I can make this 700. It doesn't really matter. Whatever number you want to start at, right? Whatever number you want to start at. How can we use this to help us here? This account number will be equal to next account number. So pull the next value from that static variable and then update that static variable so that the next time we create a bank account, it's going to grab whatever the next account number is going to be. Does that make sense? So now I can say this dot next account number. The simplest thing to do is to just add 1 to it, plus plus. That's the simplest thing to do. Some of you might be thinking about this and thinking, well, there might be some security implications with just counting up by 1. And you're right. That's an issue for another day, perhaps. A real bank account won't just count up by 1. That would make it too easy for people to guess account numbers. But you know, we're gonna worry about that another day. Does everybody understand what I've done here, though, and how this static variable makes it possible for us to assign ID numbers in this fashion? I have one shared pool of account numbers that is being used for all of my bank accounts. Anytime I create a new bank account, I grab the next available account number and I move that shared pool onto the next value. Does that make sense? We have now taken the act of assigning this account number out of the hands of the outside world and made it internal. And the constructor is now doing its job appropriately. It's set a value to all of the instance variables of this class. So the next thing that you talked about last Thursday was probably getters and setters, right? And so it's very easy to have IntelliJ create those for you, or even if you want to type them out yourself, which, you know, it's usually pretty simple to do. But I think it's an important question to ask whether we even need getters and setters. So for example, do I want getters and setters for my balance? Well, let's break it down. Do I want a getter for my balance? Do I want to be able to see what my balance is? I think that's a pretty useful thing, right? Do I want a setter for my balance? That's a little bit more problematic, I think. We have ways of changing the balance of a bank account called deposits and withdrawals, right? I can't just go to the bank and say, make my balance $7,000, right? It doesn't work that way. I can't tell the bank what to make my balance. I have to give them a deposit or make a withdrawal, and that affects my balance accordingly. So in this case, I think there's a very strong argument for making a getter for this, but a very strong argument against making a setter. That's just not how this variable is accessed. That's not how this variable works. If I want to change the balance, I need to go through the appropriate channels. I need to make deposits. I need to make withdrawals. Does everybody understand the argument that I'm trying to make there? It's up to us as programmers to identify these situations and make sure that we're not leaving ways for people to come in and give themselves $1 million if they want to, right? So we can make a getter. I don't have a problem with that. Oops, unnecessary parentheses. But if we want to change the balance, we have a way of doing that called deposits and withdrawals. So if I'm making if I want to make a method for deposits and withdrawals, right? What should the return type be? Let's talk about withdrawals first. I want to take some money out of my account. What should the return type be? A double, where that double represents what? The new balance in my account. So that's one way of thinking about it. What about any other arguments? I have a counter argument. Yeah.
Well, you need to bring up a new balance.
The new balance that's after the withdrawal. Is the withdrawal guaranteed to go through? No. I'm sure we've all been there. Go to the ATM, say I want however much money, and oh shoot, my account's low, so the withdrawal didn't go through. So I think there's an argument to be made then that we could have a Boolean. Did the withdrawal go through or not? I don't actually have a problem with using a double and returning the updated balance as well. That's a design decision that you could make, right? I don't have a problem either way. I like this way because one other argument that I'll make in favor of a Boolean is that if I want to get the balance, I could always call get balance afterwards and see my new balance. That's free. That's easy. That's easy to do. So withdrawal. And then what parameters would I expect withdrawal to have? Not a balance, but how much I want to withdraw, right? How much money I'm trying to get. Double amount. There's a couple things that we need to be aware of when withdrawing money. So the one situation that we just talked about, right? Am I trying to take out more than I actually have? I'm trying to take out more money than I've actually got. There's actually another kind of cleverly evil situation to worry about here. Think about the possible values that amount could be. There are some values of amounts that I think would be inappropriate here. Yeah. If I tried using a negative, right? A negative withdrawal is actually a deposit. I could try to trick the system into giving me money instead of taking money out of my account. So I want to be careful about that situation as well. This is our responsibility of programmers now, right? Do I want people to do stuff like that? No, of course not. But are people going to try? Absolutely. Absolutely, they will. I would never. But people would, right? So what am I going to use to check for those situations? Probably an if statement. If the amount is less than the balance. That's not the only thing, though. So how do I put another condition on here? Or, would it be or? And the amount is greater than 0. Both of those things have to be true in order for this to be a valid withdrawal, correct? Both of those things have to be true. So if I get inside of this if statement, I know that I'm okay. Yeah. If the number is too high, so there's a limit, right? I can't just take out too much money. There's actually a lot of things we could do. Actually saying if the amount is less than the balance is even a little misleading. I can't clean my account out usually. That's a separate process. So I have to keep a minimum balance. I could incorporate that into here as well. Yes, all of these things could be done. Absolutely. And I would encourage you to think about how that would work. I'm going to stick with this just to keep it a little simple for today. But yeah, absolutely. So if I get here, the withdrawal is good to go. So I just have to update my balance, correct? This dot balance equals this dot balance minus amount. And remember, the return type here is a Boolean, so I have to indicate when a withdrawal was successful or when it was not. So it was successful if it's inside of the if statement, I can return true, and it was not successful if this didn't work out, it was not successful, so I'll return false to indicate the withdrawal failed. Any questions? Any questions about that? So we've now got the deposit to think about as well. And deposit suffers from one of these issues that we just talked about as well. If I try to deposit a negative number, that's still a problem. It's not as big of a thing to worry about because you're actually shooting yourself in the foot if you try to do that, but it's still probably something that we don't want to allow to happen for record-keeping purposes, right? Bookkeeping purposes. So I still need to check to see if amount is greater than 0, but this condition doesn't apply anymore, correct? I'm not worried about over-depositing. Like, give me all your money, please, right? I'll take it. So we just need to worry about the case if amount is greater than 0. Excuse me. Oops. All right. And so now instead of a setter for balance, I've got two methods that I can use to access the balance in a more controlled way. I think that's important, right? I want to access the balance in a more controlled way than just simply setting what the new balance should be. Are there any questions about that? So then, with the few minutes of my time that I've got left remaining, we can do a couple of other little things like make a toString and an equals for this, correct? So go to generate toString, balance and the account number. Those both seem okay to me for toString. Let's talk about equals though. Do we want to include both of those in our equals method? What do we think? Just the account number and not the balance? It's possible if I'm looking at past statements, right? The balance would be different, but I'm still referring to the same account. So the account number is what really matters. So I think there's an argument not to include the balance there. If you have an argument that you want to include the balance, I would be open to that as well. I want to make it very clear here that when it comes to decisions like this, there's not necessarily a right decision or a wrong decision. It's a decision that depends on your intended implementation, the intended direction that you want your application to go. So you just need to be prepared to defend your choices. That's the important thing. Be ready to defend your choices. So there's equals. And then the last thing that we should do is test this a little bit. Oops. And I'll test this by creating a main method. So I want to create an instance of a bank account. What's the first thing I need to type if I want to create an instance of a bank account? I need to tell it the type, and then the variable name, Doug's account, equals, and then what's next? New, not balance, does start with a B though. Bank account, what's that called? What am I doing? I'm calling the constructor. And the constructor wants a balance, so $1,000 goes into this bank account that I'm creating. What's the account number going to be? We actually know what it's going to be because we made these decisions. But if I didn't have that information, right, would I know what the account number is going to be? Not necessarily. Does it matter? No. The system's taking care of that, right? The system's deciding what the account number should be, getting all that set up for me. I can ask what the account number is later if I want to, right? But I don't need to worry about what the specifics are behind that. So let's test some things out. Let's try to make some withdrawals, perhaps. Or let's before we do a withdrawal, let's print out the bank account as it exists now, so that we can compare that to the account as it exists later when we want to. So the nice thing about toString is that I can do something like this. I can just print out this variable that contains the instance of my object. It will automatically call toString for me on my behalf. So just print out the object. It will call toString. I don't have to call toString. It will do it for me automatically. Anytime you print out an object, it's just going to automatically call toString for you. And then let's try to make a withdrawal. How would I make a withdrawal here? If I wanted to make a withdrawal, what would I start typing? Object name, which is Doug's account. Whoops, can't even spell my own name today. Doug's account. And then what comes next? I say dot, and then you might have noticed this as I was coding stuff up, right? But IntelliJ is trying to help me out here. I say dot, and then IntelliJ gives me a list of all the things that are available for me to use in this position, and I stated that I want to do a withdrawal, so here's withdrawal right here, correct? How much do I want to withdraw? I'll take out 50 bucks. I would expect this to be successful, right? How would I know that whether this worked or not? What would I want to see? Yes?
Want to run the code?
I do want to run the code, but okay, well, I can run the code now, and let's see. I'm sorry? I need to get the return value. That's right. I need to get the return value. Withdrawal method is telling me whether the withdrawal worked or not. I ran the wrong thing, sorry. Where's the file that I want to run? So here's my bank account as it exists. Balance is 1,000, the account number is 700. It does the withdrawal, but then I don't see any indication of whether that withdrawal worked or not because I didn't do anything with this return value. So I could actually just print out the return value if I wanted to. That's one way. Or if I wanted to, I can make a variable and store it in a variable if I wanted to. It's up to me, whatever I want to do. And then I could, if I really want to make sure, I could print out the account again and see that the balance has been updated properly, correct? Let's try to run this again. See if we can detect those changes. Okay. Balance was 1,000. There's that true, indicating that the withdrawal did in fact go through, and I can now see that the balance is $50 less than it was before, so I have proof. If I try to do something weird, like take out negative $50, that's an invalid withdrawal now, correct? So we should see, all right, it told me false and my balances remain unchanged. So that's a good sign. And then real quick, if I do something like this where, let's say that I want, so Jenny is my wife, Jenny's account equal to Doug's account. We have a joint account, right? Can I do this? Is this okay?
So, I mean, IntelliJ is not complaining to me right now, correct? Are they in fact the same account? What happens if I do Jenny's account dot withdrawal $50? Will that affect my account? Let's see. So that's from before. Here is the balance at this line, line 62. I say Jenny's account is equal to Doug's account, withdraw $50, print out Doug's account, and you'll notice that my account is now $50 lighter. So what is this line of code actually doing? It's creating a new variable that points at the same object. In other words, I'm creating a reference. So there is one bank account, and before this line, there's a sign pointing at that bank account that says, this is Doug's bank account. When I run this line of code, I'm saying, all right, make a second sign pointing at the same account. So now I've got two things pointing at the same object, right? This is Doug's account. Oh, and this is also Jenny's account, right? It's both. It's both of their accounts. So then if Jenny comes and makes a withdrawal, well, it's pointing, my sign is still pointing at that same account, so I'm going to see those changes, even though I didn't make those directly. Does that make sense? Or in other words, if I were to do something like this, what would I expect to see? Is this true or false? It's true. It's true. There is one bank account, and I have two variables pointing at it. Doug's account and Jenny's account are both pointing at the exact same object. This is going to be true. This is going to be true, 100%. True. It's the same account. If I wanted to switch this up a little bit, right? Maybe we don't have the same account. Maybe I'm going to make a new bank account with a, I can even start it with the same amount of money if I want to, right? $1,000. Jenny's account's going to withdraw $50. Now I've got two accounts, right? Two variables pointing at two separate accounts. This withdrawal will not affect my account at all. And this statement will now be false. I've got two separate objects, right? Two different locations, two separate accounts. You can see my account hasn't changed and they're no longer the same. So if you're ever wondering, you know, how equality is going to work, it depends a lot on, have I constructed a new object? How many objects have I constructed? How many instances have I made, right? If I've only made one instance, and that's all I've got, then all other references must be pointing at that instance. All right. That's actually the end of my time. Are there any questions about this example before I turn you loose on today's studio? Yeah, what's up?
I keep getting errors, but for some reason they say frame 10 is a little fresh.
Okay, we can take a look at that. Just a moment. Any other questions before we break up? So today's studio is a continuation of the studio that you worked on with Ryan on Thursday. I will chat about that studio at about 12:30. We'll regroup and we'll go through today's studio. Hopefully I think Ryan posted his code on Slack, so if you need to refer to it, you can. Or actually, if you have your own implementation, I'd probably prefer that you just use your own code that you wrote last time. Whatever you feel comfortable with is fine. We'll regroup and do that at 12:30, and then we can also help you with the assignment that's due today. So let us know what you need. We'll be around. Thanks, everybody.